Frequency distributions, organizing raw data. A frequency distribution is a listing of the observed values and the corresponding frequency of occurrence of each value. When the amount of data is large, it is usually advantageous to construct a frequency distribution. Here in this picture, numbers are all over. It's hard to make sense of this raw data versus this graphic, which is showing a frequency distribution. It's breaking down the weights into classes and the frequency of the raw data that fits each one of these intervals or classes. Here's an example taken from an applied math class at Southwest Tech, recording the distances that students travel one way from home to the college. Looking at it in this raw format, it's very difficult to get a sense of what's going on, at least initially, without digging in. In statistics, one of the first things we're interested in is the number of data pieces, and we let n stand for the number of data pieces. In this sample that we have here, if we count up the commuter distances, there are 15 data values here. Furthermore, if we take this data and we set up classes, taking each one of the data values and recording how many are in each one, we have a frequency distribution, which tells us now the most common commuter distance one way is 28 to 36. Second is these two distances or intervals, 10 to 18 and 19 to 27 miles. Further, when we can have a graph from this data, it gives us the picture where we can see with very quick time and with ease the trend that this data is showing us rather than in that raw table format that it originally was. So some details about a frequency distribution. As I've been alluding to, these intervals are called class, and there are 6 classes for this particular set of data. The first value in a class is called the lower class limit, and the associated value is the upper class limit. Numbers ranging from 0 to 9 will fall into this class interval. We can determine the class width by taking any one of the intervals then by taking the upper value or upper limit minus the lower limit. So 9 minus 0, each class width is 9, and that's maintained throughout each one of those class intervals. From there, we then go through our table of data, and in this first class interval, we are looking for data values that are more than 0 but less than or equal to 9. And in our data from this sample, there is one student that commutes 0.2, so we'll put a 1 for our frequency. In the next interval, we're looking for values that are more than 9, and so we have listed our lower limit as 10 and our upper limit as 18. So data values need to be more than 9 but less than or equal to 18. And looking in our raw data values, we have 3 that fit this criteria. The third class interval is 19 to 27, which means it is more than the 18, the cutoff on the previous one, but less than or equal to 27. Identifying those values in the table, there are 3 for this interval, and we would continue on for the balance of the intervals. Here we have another example from a different class, again recording the commuting distances of students one way to Southwest Tech, and the raw data values have already been tabulated into a frequency distribution. Can you determine the number of students in this data set? Well, to determine that, we are going to add up the frequencies in each one of these classes. And if you add those numbers, you should come up with the total of 27. How many classes are there? If you answered 5, you would be correct. There's 1, 2, 3, 4, 5. And then for class width, if you recall, we take any interval, and in this case, starting at the top one is probably the easiest. 6 minus 0 gives us a class width of 6. In the next class interval, if you take 12 minus 7, you do get 5, but you're not counting that 7. So we need to add 1 onto that. If you count 7, 8, 9, 10, 11, 12, there are 6 numbers in that interval. Here's another example of grade point average that's been tabulated into a frequency distribution. And again, the same set of questions for the most part. They're asking us how many data values were in this problem. And to determine that, we will add up our frequencies, in other words, the number of data values in each one of these intervals. And if we add that up correctly, you should find that it's 139. How many classes? Well, we're looking at the classes here, the range of values. If you count, there are 8 classes there. The class width, the easiest is to subtract here in the first interval with the 0 in it. Next, they're asking us to look at the fourth class, 1, 2, 3, 4. Determine the lower limit, well that's 1.6, and the upper limit, which is adjacent to it at 2.0. The last question, a GPA of 1.5 belongs in which class? And if you recall, the values in this interval, in this first choice, are 1.1 to 1.5, but not greater than 1.5. 1.5 equals 1.5, so A is the correct answer. B is anything greater than 1.5, which we start with the low end, the lower limit of 1.6. At this point, we're going to stop, and you should be able to practice some of these new concepts by doing problems 1 through 3 on the Understanding Frequency Table worksheet.